This is day 16 of Advent of Code 2023, and this challenge is called The Floor Will Be Lava. With the beam of light completely focused somewhere, the reindeer leads you deeper still into the lava production facility. At some point, you realize that the steel facility walls have been replaced with cave, and the doorways are just cave, and the floor is cave, and you're pretty sure this is actually just a giant cave. Finally, as you approach what must be the heart of the mountain, you see a bright light in a cavern up ahead. There you discover that the beam of light you so carefully focus is emerging from the cave wall closest to the facility and pouring all of its energy into a contraption on the opposite side. Upon closer inspection, the contraption appears to be a flat, two-dimensional square grid containing empty space, mirrors, and splitters. The contraption is aligned so that most of the beam bounces around the grid, but each tower on the grid converts some of the beam's light into heat to melt the rock in the cavern. You note the layout of the contraption, the puzzle input. So it looks like something like this. The beam enters in the top left corner from the left and heading to the right. Then its behavior depends on what it encounters as it moves. If the beam encounters empty space, it continues in the same direction. If the beam encounters a mirror, the beam is reflected 90 degrees depending on the angle of the mirror. For instance, a rightward moving beam that encounters this mirror would continue upward in the mirrors column, while rightward mirror beam that encounters this one would continue downward from the mirrors column. If the beam encounters the pointy end of a splitter, the beam passes through the splitter as if the splitter were empty space. For instance, a rightward moving beam that encounters a dash splitter would continue in the same direction. Okay, yeah, so it just passes through, but if the beam encounters the flat side of a splitter, the beam is split into two beams going in each of the two directions. The splitter's pointy ends are pointing. For instance, a rightward moving beam that encounters a flat splitter like this would continue in two beams, one that continues upward and one that continues downward from the splitter. Beams do not interact with others. A tile can have many beams passing through it at the same time. A tile is energized if that tile has at least one beam pass through it, reflecting it or splitting it. In the above example, here is how the beam of light would bounce around the contraption. So it first hit this one would go up, but so there's nothing there. It'll go down, it goes into another splitter, so it'll go this way, this one, it would continue straight, this one would go up, then this one would go right, I think. And this one would go down, this would get split in two directions, and this one would go right, but then that would go down, but then that one would go up, left, up, like that. Then that would split it, then that would split it, and this would go up to here, and then that one would go back to following this path. Okay, that makes sense. Beams are only shown on empty tiles. Arrows indicate the direction of the beam. If a tile contains beams moving in multiple directions, the number of distinct directions is shown instead. Here is the same diagram, but instead only showing whether a tile is energized or not. Ultimately, in this example, 46 tiles become energized. The light isn't energizing enough tiles to produce lava. To debug the contraption, you need to start by analyzing the current situation, with the beam starting in the top left heading right. How many tiles end up being energized? Alright, so let's get started with that by copying this input to here. So this is going to be run recursively. You're going to have a function where you're passing in, we're going to be passing in the location that it's on now, and then the direction it's moving. So def move loc and direction. So we're going to be also, so we're splitting this, we need to, okay, it's not this anymore. It will be cell in for cell in line strip. Already got that part. Right, there we go. So we've now got a cell, and we'll change this to grid, and we'll have previous inputs. This will be a dictionary. So as we saw with this one here, this one went right, and then it split down, but then also this part here went left, split down. But what we want is this one is going to have the same thing twice. It's on this cell and it's moving downwards. If you get to there twice, then that's when you exit. So we would keep record of that in here. Actually, we'll make this a set, and this will be previous inputs. If loc direction in previous inputs return, otherwise previous inputs are add loc direction. And how do we want to do this? So we need to keep track of, I guess initially, just so we have something. So we'll start off with move 0, 0 east. So previous inputs add So now we need to... Actually, what we'll do instead is do a dictionary, and this will be if loc in previous inputs and direction in previous inputs loc. That's how we'll do it. If it's not, then previous inputs loc dot append. Actually, this will equal previous locs dot get loc plus direction. So if it already exists, we'll get the list that's and then add direction to it. If it doesn't exist, we'll get the empty list and then we'll add direction to it and add it to there. So now we'll have a key of 0, 0 containing a list with one item of E. So there are what are the different types of cells? So cell equals grid like 0. Actually, this will be like 1 like 0. If cell equals dot. Actually, we need cell equals dot. Then we'll just say if direction equals north loc. Then this will just be move. Then this will be loc equals loc 0 loc 1 minus 1. Then we'll just do basically the same thing for everything else. Do north, south, east, west. This will be +1. This will be +1 minus 1. And then it'll be move loc direction. And I guess what we also need is if loc 0 less than 0 or loc 0 greater equal to length of grid 0 or loc 0 less than 0 or loc 0 greater equal to length of grid return. So I think this for cell that works fine if it's a dot. Elif, actually we can do or direction in east west and cell equals dash, or then the same thing but north south cell and it's pipe. Do that, and I guess we can just do the same thing here but like this. Then we can do if direction in this move. Actually, where do we have? Grab the location here. This will now be. We'll have a north location, which is this, and then a south location, which is this, and we'll do move loc north, move loc south, and this will be north south. Then we'll do the exact same thing but for these ones. So we'll do an east west and east west. And now we need to do elif cell in slash or slash for the also just to do an else something isn't working, just in case we do mess up. So how do we want to do this? So if we're going east, this one goes down, goes up. I guess we'll just do a massive if statement. If direction equals east 1 2 3 elif if cell equals this will be loc, so east, and it's on this, so we're going to go south. Oh, forgot to change these ones right here. So south is this one, else north, direction west, north, south. So for the west one, it's going to be flip, so this one's north, -1, to be plus, this is south. Then basically same thing again for this. So if you're traveling north, this is east, west, and east is this, so that means west is that. And now for south, these get swapped around, so west, east, negative, positive. And I guess part 1 return previous location dot keys, the length of it. Let's see if we've got anything wrong with it. Okay, well that should have just returned 1. So let's do print previous inputs. So I just only did that apparently. Okay, let's go through this. Print loc, then direction. So it did get to here, but then what did it? Didn't seem to do anything. So let's slowly go through and see whereabouts 10 stopped. Okay, so it stopped somewhere here. So apparently, so I didn't do that one. So it failed there. Okay, so loc, I guess we need to print out these as well. Okay, what have I done with grid? It shouldn't be printing out 1 there. I did equals dot append. There we go. Okay, now see if it works. It gave us 29, which I'm pretty sure was wrong. It should be 46. So I guess let's go back to this and print location direction. Now we can follow the flow of this to see what was going on. So started here, fine, went here, east. Okay, why is it doing the negative ones? Oh, right. Wait, it should have exited. Okay, well I forgot to do the numbers there. Okay, now let's run it. Okay, now it's going to 17. But we'll put this below that one just so we can see. Okay, so it went here, here. It went south all the way to 7. 0, 1, 2, 3, 4, 5, 6, 7. Went east, 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 north. Okay, that's not right. North to that one. What did I write for that? Okay, I think I got these mixed up. It's going south to this. This should be... Let's just swap these around. Now let's rerun it. 46. That actually sounds correct. There we go, 46. So let's get our input and put it in there. So now run it. Maximum recursion depth reached. Huh, okay. So firstly, let's remove that print statement. Just gonna quickly run it again. And which challenge was it? One of them was system this one right here. We are going to grab that and we are going to import this in, and let's increase that to 1,000,000. Now let's see what it does. 6740. So if we go back to here and put that number in, we have now got part 1 completed, so on to part 2. Okay, so part 2. As you try to work out what might be wrong, the reindeer tugs on your shirt and leads you to a nearby control panel. There, a collection of buttons lets you align the contraption so that the beam enters from any edge tile and heading away from that edge. You can choose either of 2 directions for the beam if it starts on a corner, for instance. If the beam starts in the bottom right corner, it can start heading either left or upward. So the beam could start on any tile in the top row, heading downward, any tile in the bottom row, heading upward, any tile in the leftmost column, heading right, or any tile in the rightmost column, heading left. To produce lava, you need to find the configuration that energizes as many tiles as possible. In the above example, this can be achieved by starting the beam in the 4th tile from the left in the top row. Using this configuration, 51 tiles are energized. Find the initial beam configuration that energizes the largest amount of tiles. Okay, so I think that shouldn't be too hard, but we are going to need caching for this, so let's grab that, import that to here, and at cache here, so I guess we will do reinitialize that, and we'll do for I in range grid, and then we'll do total equals list here. So for I in range grid, we'll start off with this. So you've got total list, this, we do move, so for grid that is top to bottom, so we'll do east, total dot append length of keys. We will then do this again, so this is 0 plus I, and then this will be the same thing below here, but it will be length of grid 0 minus 1, and this will be west. Then we will do the same thing for here, but it'll be I grid of 0, and this will be 0, 0 plus 1, which will be north. Wait, this will be south, and then swap around again for north. Then we return max total. I think that's how it'll work. Actually, let's try this on the test one first. List cannot be interpreted as an integer. For I in range grid, what I do range, this should be length, and then length here. So now run that. Gave 0, which is wrong. Okay, so that must be, actually maybe I can, here, can I return previous inputs? And then we can do, Actually, I could just pass previous inputs like this. So now we have references to it. Still 0. Let's print total. So it's all just zeros. Print previous inputs like that. Okay, so it's definitely working in there. Okay, no, I don't need a... This passing it does nothing. Actually, let's do print length previous inputs dot keys. What is happening in that? Okay, so it's not getting reset at all. Oh no, reset inputs. Does this do anything? How do I access this? Right, actually we can make variables global. Do you like global like this? Previous inputs. That partially worked. Print previous. So return. Maybe we just need to do this. Actually, I forgot to do the append here as well. Okay, well, it returned 46 for some reason. Maybe in here I also need to do global previous inputs. And then I wouldn't need to be returning it. Do I? Could it be that the caching is the issue? Maybe remove that? Huh, okay. So we're getting 48 now, but it should be 51. And does it say which tile that occurred on? Fourth tile from the left in the top row. 0, 1, 2, 3. This one? So 2, 4, 6. This one should be one of these. Let's do move if 0, 4 print previous location, previous inputs. Okay, that was... Oh, okay. If loc equals that. Actually, that should be 0, 3. Okay, well something's definitely not going correctly with that. I guess we can test with this. 0, 3 south. It's getting 7. Let's print this to see what's going on. So 0, 3 goes down, down, keeps going down till 0, 1, 2, 3, 4, 5, 6, 7. Wait, did they change one of the conditions? So she tried to work out... Wait, no. I'm not sure what's up with this. So I get... My results is just it goes down, and then that's it. Why didn't it split there? Did I do the wrong thing for that? Oh no, that's correct. Oh right, I'm doing it the other way around now. So it should be 3, 0. So that's XY. Well, that returned 51, which is the most one. So what have I done with these numbers? So something here's just not working. Well, I guess one thing we found out is this was wrong. It should be this is doing east. That increases, that's correct. West, the X is on the other side, so like that. And if we're going south, we're going top row across, like that. I'm not sure what I changed, but now it's getting 51. So change this back to like this. Get rid of the prints. Okay, we're getting the correct answer, but I have no idea what I changed. But, I mean, we'll now give it into the real input. I've got a feeling this is going to take a long time. Okay, maybe not. Not as long as I thought. But we've got 7041 for the actual longest, or actual best one. And that is the correct answer. So that is day 16 of Advent of Code completed. If you like this video, make sure to like and subscribe so you can watch me complete the rest of these challenges.